Hello everyone, nice to see you again. I'm Chris. In this video, I will show you how to use Beckhoff.Let to configure EtherCAT network to a Delta servo system. And this system is ASDA-A3. It's made by Taiwan, and I'm making it step by step from zero. I hope you enjoy this video. Let's start. Okay, before we continue this video, let me introduce myself again. I'm Chris. I come from Hong Kong. I'm working with some stuff that with factory automations, and if you're interested about my post or my contact, here is my blog, my YouTube channel, and my X or Twitter. You can follow it. Okay, so before we start to use this Delta ASDA-A3 drive, you need to go to this link to download the ASDA software to configure your servo motor drive, and also because we are using EtherCAT network, you need to download the ESI file. And here is the screen of the configuration tubes. Make sure that you set to P1.xxx and P1.001 to C. C is meaning using EtherCAT. You can reference the manual to get more information about that, but just remember C is meaning configure the drive in EtherCAT mode. And here is a very important information that when you try to configure a servo drive, it's a screenshot from the manual of the Delta ASDA-A3 drive. Is a version of ASDA-A3 is 24-bit. It means it generates 16777-216 pulse per motor revolutions. And what do you mean? It means that when run revolutions, then you generate this type of pulse. So you need to take care actually how the distance of each revolutions to your system. Then you need to configure it in TwinCAT, or even if you're using Amlon PLC or Mitsubishi PLC or any PLC to configure this point. And for the mode system, they also have something like E-gear ratio. I think called this, they call the term in here in Delta ASDA-A3. Now I just set it to 1. It means that per revolution, I will get 16777-216 pulse. And here is a setting in TwinCAT. And go to Access, and your access that is configured with ASDA-A3 servo drive. And go to Encoder. There is a setting for scan the reflector and scan and the reference system. For reference system, so make sure that you are setting it to increment, because the encoder now I'm using in this system is increment. And also I config 167777216.0, then will be 100. It means if any 167777216.0 pulse, then it means 100 mm in my TwinCAT system. And also in this project, I'm using interface properties, methods, and function block. So it means I will create the interface of a function block. I create the properties of a function block, the inside interface, and the method in the interface, and I'll use the function block, and I'll implement this interface, and I'll use the other function block to extend the function block that I'm using. I hope this video will give you a very basic concept to how to use the OOP programming in TwinCAT. Okay, I think my talking is enough. Now we can turn on my camera to see actually what the hardware that I'm using in this time. Okay, now I turn the camera. As you see here is the PC, the mini PC that with the TwinCAT installed inside. I'm using still a old version 4024, but I think it's not so big different to 4 or 2046, because basic concept is same. And here is a transformer that let me to transfer the voltage from 100 to 200, because I'm in Japan. In Japan, basically it only supply 100 in my home, so it's up to 200, and then to supply to be the input of my servo drive. And here's the servo drive, and here's 2 port. 1 port is for EtherCAT, and 1 port is for engineering. And I think the instruction here is enough. Now I can start the programming. Let's go. Okay, now we open the TwinCAD XAE. We can start to make the program. So the first thing is you need to make sure that your TwinCAD system is connecting to your TwinCAD runtime. So go to System, choose TwinCAD, and now you can see I'm connecting to the TwinCAD runtime that I would like to connect. If you doesn't have connect this one, go to search Ethernet and enter the IP and add the root in your system. Okay, and the next thing I would like to add the Ethernet master. So go to IOs, device, right click, add new items, and choose Ethernet master. And the Ethernet master is added in your system. So go to adapter, search to choose the adapter you'd like to use as a Ethernet master network. And then I can use the scan network. So go to right click, scan. Then I scan a drive. In this case, Delta ASDA-A3 series servo motor. Then TwinCAD asks you, would like to configure it as a NC configurations or CNC configurations. At this time, I'll configure it as a NC configurations. Okay. Great, you see a NC access is added in our project. Okay, I'll show here access 1. You have encoder, drive, control, input, outputs. Okay, then now we need to set up some parameters. The first one, you need to go to encoder. You need to go to the parameters. As we mentioned before, that for each resolution, this servo motor drive will generate 16777 to 16.0 counts. So what do you need to do in here? So just input here 16777 to 16.0. I would set one solution revolutions will be 100 mm. So it just depends on applications. So just make sure that it's set clearly. And the next one, you need to set the reference system. In this time, we are using increment. In some encoder, you may need to use an absolute. That just depends. Please check the manual of your system and to set up a correct configurations. Okay, then other options I would like to set is the parameters. I think it's monitor. There's a monitor called position log monitoring. Before the tune the drive, this monitoring in case you have any error so many times. So just break it to false at the beginning. Okay, I'm gonna save my project, and then we can download the project one time. So go to activate configurations. Okay. Yes. Great. Okay, you see the project is download. Then we can go to access. We can go to online. Now some values in here. It means that the communication between TwinCAD and the Delta motion drive, Delta server drive is communicating without any error. Then we can press the set button. We can press O. Now the servo motor is enabled. Now we can press the Go button to make the operations. Okay, so we can turn it off again. Okay, turn it off. Great. Okay. After that, we can start. Then we can go to make the program. As I mentioned before, that in this time we use interface, and in the interface we will define couples of methods, properties, and use function block to implement that function, the interface, and then we will use another function block to extend that function blocks. So let's do it step by step. Go to add the PLC first, right click PLC, and then extend the project, and spend some time to create a new project. Yeah, because my computer is not very high performance. Maybe you need to be time. Okay, now I think that's creating. Now the project is done. Then we have opened it. Go to poise. I will add a folder. Add new folder. I call it speed access. So it is all the stuff inside this folder will be using to control the the axis is a speed axis. So if I add interface, add, then interface, then enter the name of the interface. In this case, I'll use speed axis. Okay, now in here I add interface. So as I mentioned before, that the interface it will define what this object should do, but it will not define how it do. Why we use that? So maybe we have different types of servo drives that we have same features, but in different way to implement it. So you can use function block defining one by one, but by using interface, then you can standardize this type of stuff, and then you can pass the interface as a data type in your parameters. So it depends on what you want to do. Okay, so the first thing I would like to add a method. So it should be, I would like to stop the access. This method using to stop the access. I would like the return type to be inch. Then there I will put a command is bool. Okay, finish. So in here you no need to define how to do it, just to define what you want to do. Okay, do the same things. Then I will have a I will define the joke. Just copy it and change the name to joke. Joke forward backward. Yes. And then here, this time not have I command. I'll have I forward, and I have I backward, and also have a I set point for operate the access in job operations, the speed, and I have a accelerations, and also the derivations, the VLDC. Great. Okay. Then I have a power on method. Okay, here no error, right? No error. Okay. Then I have a power on method. Oh, I will not copy this one. I will just copy the first one. Then here I'll call it power on. Great. So for the power on, also have just a function, a command, a bit command to turn on or turn off my servo motors. Then I'll also have a reset for me to reset all the alarms of my function block, of my servo. Just also have a I command. Okay, great. I save it and then close all one time. Then I will have a method that to just copy. Okay, just here of a method. It is run the servo motor at a constant speed. OC velocity command. It will be inch. Okay. Then inside I will have I command, right? And then I have I set point, the speed set point, and also have the other restrictions and these restrictions I DZZ. Okay, great. And then I would like to define a couple properties. Right click, and then here the first one I would like to define is I would like to check the communication is okay or not. It should be return a bool type, and then I just would like to get method. I don't need the get set method, and then set properties, and then I just copy it. And then the next one, I will also have a property to me to get the error status, and then okay. Also have only have a error with get status. Then after that, I will have a MC status to get the status of my servo motors. And I would like to add a library in here, MC power. It is sometime okay. I'll need to add this library mc2 underscore tc2 underscore mc2. Then add it in my system and close over this. And here my return value should be SD access status. Great. Okay. Then I have a property to let me to return the actual positions. So I'll call it read actual position. Then only have the set method, get method. Okay. Then I will have a property to get the current speed, ELVELO. Speed is okay. Speed is PED. Okay, great. And then I would like to have a property to get the drive is ready or not. So I'll copy this one and then we name it to ready. Great. And then copy again. And now I have a status called running. And then finally I have a status called, I would like to auto check my servo motor is stopped or not. So I have a property called stop. Great. Then I'll close it, close over this. Let's check, double check it. Boo, ready, view, access. Okay. I think we done this one. And then we close it, or close all. And then after, I would like to create a data type for the return value of my method. I would go to here, the point. We go to DUT folder to add a DUT elementations. I will call it axis axis basic returned basic return value. And then I will have some data types for that, some value for that. Insuline, and then error, and then done, and then busy, and then none, and then in university, OOCITY. Great. Okay, then I close it. Now we can add the function block. So go inside the speed access folder, right click, add point, and then choose function block, and the name is function fb delta ASDA-A3 speed access. Then it's a function block that implement with the interface we done before. So it should be applications, deploys, and then we find our folder, speed access. And then the method, you implement a method in the ST language, but also the whole function block. Open it. Done. You see all the methods and property is predefined here. Then when you open these methods, they'll have a warning here to add the method implementations. That means that if you compile your project, then you get the error that to mention you that don't forget to implement your method. So let's do it one by one. The first thing, I would like to define some in-out. I would like to define access for me to use. IO access is reference, REFERENCE, reference to access reference. Great. And I will have some function block I would like to use in here. Underscore MC power is MC power. and have a underscore MC reset, it should be MC reset. And have a MC half, it should be MC half. And have a MC joke, it should be MC joke. Great. And now have a MC move velocity, it should be MC move velocity. And have a MC read actual position, ACTUAL POSITION, it should be MC read actual position. And then I'll also a function block to read the current speed, ACTUAL VELOCITY, it should be MC read actual velocity. Then I'll have a MC read status, it should be MC read status. Great. Okay, all the big stuff is done. Now we can implement the functions one by one. So go to the first one. This is a method for me to stop the access. Just delete the warning first, and then I will define a instance in here, RTRIG. So what is this one? This keyword is allow you to define instance can be used in your method, and by default the method cannot save the status of your result. It means that you cannot define an instance of function block inside a method. By using this one, you can use this way. If you don't use this keyword, you need to go back to function block and then to define a instance here, then use in the method, and this not makes sense. So I think this way is very more easy, or more makes sense way to use function block inside a method, and you not duplicate the name. So the start programming, R trigger CLK is equal to what? CLK is equal to I command. Great. And then we can call a function block mv half. The access is equal to IO access, and then execute is equal to I command. Then we also need to configure the declarations. This one, let's give it default value, 100 or something, and then oops, and then done. Great. Okay. Then after we call a function block, so if we detect a signal, for the command, then we will turn the return value method half is equal to e-access basic return value dot none. And then if MC half dot error, so it means there's some error, then we will define return the value as e-access basics dot error. Then else if what? Else is underscore MC half dot, if this time it's running, so it's busy, busy, then we can return the value to e-access basic value dot busy. Then finally, else if MC half dot done, then we can return a MC dot what is equal to e-access dot done. Great. Okay, finish. Then we can do the other one, same one for the joke. We need to first of all we need to delete this warning first. Then we can copy the define here. Then this part should be same. Okay. And then this part just to be different. Equal to what? It should be equal to something. So I forward, backward it should be bool type. Great. Then forward is equal to I forward and not I backward. And then backward is equal to I backward and not I forward. Great. And then what you check? You will check over something, right? It should be forward and not backward, over backward, backward and not forward. It should be something like this, right? Okay, then we can call our function block MC jog axis is equal to IO axis, and then jog forward, jog forward is equal to forward, jog backward is equal to backward, and then we will have the speed is equal to I VLEC set to point, and then we will have the iterations. This should be I VLC ACC, and then we also have the decelerations is equal to I VLE DZ, and then the mole is equal to M equal to E jog mole dot MC jog mole continuous. Okay, great. And then let's do the same things. Copy this one, placing here. If there is running, and then we can change the value to loon. Then if MC jog dot error, then method jog is equal to E axis dot error, and then else ELSIF else MC jog dot busy. Then we can return the value to E axis dot busy. Not difficult, right? Okay, then we can go to other method. It's called power on. Saving, delete the warning, and then copy the instance in here. Then soon it'll be big, and then here it should be same. Here it should be same. Okay. Then call the MC power function block access equal to IO access, and enable is equal to I command. And for enable to the positive and negative, I will give it default value to true, equal to true, and enable negative also equal to true. Then it should be done. Okay. Then if now the command is trigger, then we can set the return value to E access basic dot num. Then if MC power dot error, if there's an error, then we can return the status to error. Then same else if MC power dot busy, then we can return the value to E access basic return value dot busy. Then if it is enable, then we can return the done, E access done. Great. Okay, next one. Okay, just copy here. Is the reset method. Same thing, delete and add an instance and copy this one. Okay, and call the function block. Reset access is equal to IO access, then execute is equal to command. Finish. And then we can just copy the command from here. Okay, and then paste in here, and then change to here, error BZ, and oops, not this one. Okay, error. Change all these ones to same correct name, and change the function block status to reset. Great. Okay, done. Then we have a function block to operate the access in a constant speed. So just close all unused stuff, close over but this. And then first of all, same to here, copy. Okay. Same thing. That to detect the H up signal. And then call the function block. The function block is MC move velocity, and access equal to IO access, and execute is equal to I command, and velocity is equal to I set point, and then with isolations is equal to I VAR ACC, and DC is equal to I VSDC. Great. Okay, and then we can just copy this one again. Just change it a bit inside. First of all, the return value with the return name, and then this one if error, if busy, and then if in velocity, then in velocity. Okay, done. Great. The next step, we can start to configure the properties. The first one is communication OK, right? BLP communication OK is equal to not IO access dot status dot IO data invalid. Great. Next one is the error. Error so easy. Error is equal to what? Equal to IO access dot status dot error. Then we will have a MC status. MC status, what we need to just call the function block MC read status. Oops, read status. Then MC read status. Great. And then we have an access equal to IO access. And then we will have an enable equal to true. Great. Then we'll return the value MC status equal to MC status MC read status read status dot status. A status dot status right. Then we can get the current positions, doing the same thing, MC read actual position, and then access is equal to IO access, and then for the enable is equal to true, and after that we can just return the value is equal to MC read actual position dot position. Okay. Then we can read the actual speed. MC read actual velocity. Access is equal to IO access, and enable is equal to true. Okay. Then PROP read actual speed is equal to MC read velocity dot actual speed. Great. Okay, I think this point also done. Oh, you need to delete this stuff. Even you have warning. Okay, just delete this one stuff in here, all the stuff in here. Okay, and then close over this. Okay, I think I do this one. Okay, ready. Now it's ready. So just delete the warning message. Then go to get. For ready is PROP ready EADY dy is equal to IO access dot status dot operational. Then for the running, I will delete this one and go to get. Then PROP running is equal to IO access dot status dot moving. And then if it stopped, also delete here and then go to here, and dot stopped is equal to IO access. IO access dot stopped dot status dot not moving. It's done. Okay, so we create our first function block for the speed control access. Then we can close it, close all documents, and then now we can create new folders. By the way, you can build it by clicking no, because now this block is not using, so you compile it, and then we add a new folders. Add folders. The folder name should be position POSITION access. Okay. Then we can add an interface again. Interface. Okay. So this time this interface name should be position access. It should be extend from display access interface. Okay. So here you see the position access is extend from the speed access. So then we can add our own method in here. So first one I would like to add is a home method. Home. Then I have a one input called I command. Okay, great. Then what you need to do here, just copy, and copy and paste. Great. This will not use, and this one it should be execute a absolute positioning ABS. It's okay, I think. And for the interface, it should be a little bit more. I have a speed set point. Right. I also have the accelerations and the decelerations, and also the position command. Okay. And then what you need to do is just copy and paste, and then paste it, change the name to LEL, and then here same, just change to this one to I distance, DISTANCE. Okay, just 3 methods. We can close it, close all documents, and then we can add a function block again. Function block, and this time you implement the position axis and also extend the function block of spec axis that we add before. So name, it should be FB position axis. Okay, now you see that here is some method is with error, add method invocations, or delete method to use the base implementations. So if you don't want to override the original probabilities or method, just delete that. I will delete this one. I will delete this one. I would delete power on, reset, and command. Just delete. Right. And for the probability, also you need to delete or add your own implementations. So I'll not use this one. I'll use the basic one. So what I need to do is just select and delete. Great. And then compile it. Okay, you will not have any error, and then we can define the interface. The first thing we need to use is MC move absolute. ABSOLUTE is MC move absolute. Then MC move relative, relative is MC move relative. Then with the MC home, it should be MC home. Great. And then we can call the method here. Delete the warning, and then copy this one. Copy this one and place to here, and then we can copy this one. Copy all and delete this one, and MC home, then axis is equal to IO axis, and execute is equal to I command, and position is equal to 0.0. And then for the homing mode, I will use MC homing mode dot directly, MC direct. Yes, because if in the real applications, maybe you will have a sensors, one or two sensors. The first one will be go back to backward, and then until you see the sensor, and then go to forward a little bit more, and then go to backward, just in case. But because now I didn't connect to this sensor, I just use it MC direct to refresh the actual position value to 0. Yeah, but just in case, right? And we can change it to MC home, right? If MC home dot error, if MC home dot busy, and if MC home dot done, and then we change the name in here, and then if busy and if done, right? It works. Okay, then you have a move absolute function block method, and just delete this one. Actually, it's same in here, and then just delete the function block side, and MC move absolute, and axis is equal to IO axis, and execute is equal to I command, and position is equal to I position, and then associations equal to I ABC ACC, and visualization is equal to IVLDEC. That's off. Okay, and then just change the return value, not home. Now it should be absolute, and then you can need to change the so if error, if busy, or if done. Great. And then we can do the same thing, but you need to also copy this one. Yeah, okay. Then we need to do the same one for here, copy, and then delete this one, and then copy whole page, whole stuff in here, and just MC move REL relative access equal to IO access, and XQ is equal to I command, and distance is equal to I distance, oops, I dis distance, and I will have this set point, the speed, B is equal to IVLS set point, and I will have the associations is equal to IVCACC, same, and also for DC. Great. Did I set the speed? I think I set the speed also, right? Oh, I didn't set the speed. Oh my god. And V is equal to IVL set the point. Great. 1 2 3 4 1 2 3 4 5 6 1 2 3 4 5 6. Okay, say 1 2 3 4. Okay. Then you need to, for example, you need to change the return value name. Okay. Then you need to change the function block using here. So it should be error if FBC and if done. Okay. Great. Now our function block is done. The next thing, we can create a GVLU. Right click, add GVLU. Just call the name that you like. I'll call access. For here, it should be access array 0 to 9 of access reference. Delete the things you don't need, don't want to use. Close all the things you don't want to use. And then now we can build one time. Great. Then we need to link the access reference to our hardware access. So go to access 1, I think it's access 1. Go to setting, link the PLC, and then choose the instance you would like to link. So I choose the first one. That is finished. Okay, then I would like to add a function block, add a program. So in the main, is to call in the main. So add program p servo. So I would like to call from here p servo. Great. Then build it. Okay. Then we can go to main. Not main, go to servo. We can define the details we would like to use in here. I just drop it to little bit easy to see. Access 1 is equal to FB delta position. Oops. Okay. And I think I need to change the name to make it a bit more easy to see. It should be effectual. FB Delta ASDA-A3 position access. Okay, great. Then I have a status is SD access status. Great. Then I'll have a B for work, B back work, and B home, and B move ABS, B move our yellow, is some command. Okay, then have B communication. Okay, B error, B running, and B stopped. Okay, a little bit long, and then have B stop, then have B power on, then I have B reset, then I have some return value for absolute positioning, return value for relative positioning. Then I will have a signal for B ready and B run and B stop. Okay. Then I have some set point value. B set value is real. Then F32 ABS pose, F32 ABS VEC. Okay, just pose in here. Put a LEL and F32 ABS VL is speed is real, equal the default value to 100, and F32 ABS ACC 100.0. Okay, and F32 is ABS EEC real equal to 100.0. Then we just copy to here, keep space, and here AUL, and AUL. And then finally I will create some variables for the sample program. I step and T on and I start, I stop, and my counter. That's off. Great. Okay. Then let me to call the function block and then to let the program compile first. Access 1 and our access equal to g value access dot access 0. Okay. And then let me to build it one time. Oh yeah, it's some error, cannot convert types. Yeah, because I didn't copy it, I think. Yeah. And here, okay, it should work. Reset, and it should be command, okay, and build it. MC reset. Okay, I have some error here. Okay, let's do compile again. Great, no error. So this one is not just an error that without the TCP license. So no need to take care about that. Close all documents and open the B server again. Okay, and then we can power on our server is equal to access1 dot method dot power on, and I command is equal to B power on. Then we can get the status. Okay, B ready is equal to access1 dot method ready not ready property PLP ready EADY, and then B running is equal to access1 dot PLP running, and then B error is equal to access1 dot PLP error, and B stop is equal to access1 dot PLP stopped. And then I will have a B communication OK is equal to access1 dot communication OK here. Okay. Then I will have a status. Status is equal to access1 dot PLP. What's that? MC status. Great. And you'll get the current speed is equal to access1 dot PLP read actual speed, and then I'll have a position actual position ACT. I don't have the actual position. Why? Actual speed. I have the actual speed. Oh, maybe I didn't define it. Sorry. Let's find some place. Maybe here. Okay. And actual position read. And actual position is ACT. Okay, ACT. Okay, ACT position. Actual position. Actual position. ACT UAL. U is equal to access1 dot PLP read actual position. Then we can start to call some functions. The first thing we would like to reset, we need to reset our function block, our access dot reset, and I command equal to B reset. Great. And then if return, I just show you some case for use the return value. If the return value is equal to B access basic return value dot BZ, then maybe you can we can just reset the signal. B reset is equal to false. Okay. And then return value is equal to access1 dot method underscore half. Then is to stop the access. If we turn, then we can also use some other functions, some other status is equal to B stop. I think it's B stop. Yeah. And if status status dot stopping or status or B error, then we can stop the signal to false. Okay, just continuous. Then we have a home method, RET equal to access1 dot MEETH home. I command is equal to I think it's B home and if okay, no need, I think no need. And then return value is equal to access1 dot method speed command, yeah, and I commands is equal to b run, and I speed set point is equal to f set value. And then for these two, just give some constant value because I will not use this one actually, to 100 and finish. Okay, and then we have a joke is equal to access1 dot method joke for the backward, and I command I forward is equal to b forward and not b backward, and I backward is equal to b backward and not b forward. And then set point, just use the same one, is okay, f set value. And for ACC and DC, just a constant DEC 100.0. okay, I think it should work. Okay, then we'll have a VAL, BET, VALUE, ABS. Do the absolute positioning. ABS, move ABS, and I command is equal to B move ABS, and I speed set point is equal to F22 ABS VL, and I VL ACC is equal to F32 ABS ACC, and for DC ABS DC, and then 1 2 3 4 1 I position is equal to F32 position, yeah. And then RET, then we have a relative is equal to relative positioning dot METH and move REL, and I command is equal to B move REL, and for set point is equal to B32 speed set point, and for the ACC is equal to F22 ACC IVL DEC is equal to B32 EL DEC, and I distance is equal to F22 this REL distance. Oops, BIS. What's the name? I forgot. Pose. Pose. Okay, that's great. Okay, for the basic one is done. Then just do some reset, show you some case of how to reset it. But if status dot moving or B error, if any error, then we can B run false, and B move ABS false to cancel the command of the movement. Great. Then finally we can make some simple program. Case I step off to test it. For step 0, then we can reinitialize all the things. I stop command to false if I start and I step is equal to 0, then I step is equal to 10, and I start is equal to false, and my counter UNTR is equal to 0. Okay, then go to 10. B move ABS is equal to true, and F32 ABS position is equal to 1000. Let's give a set point, and then if GVL access dot access 0 dot status dot moving, then I step is equal to 20, and B move is equal to false. And then we go to 20, and sorry, I don't have any error processing this time, so you need to program the error process by yourself. Is return value ABS is equal to access access base return value dot done. Then we can change the step to 13. Then go to step 13, and B move relate is equal to false, and F32 relative this position maybe equal to minus 200, and FGVL status dot access 0 same status, the dot moving, then we can change the step to 14, and B move relative can set to false. This is true, not false, sorry. That is true. Okay. Then finally we can go to step 14. Then we can B if return value is equal to access dot done, then if not I stop, it means there's no stop command here. Then we need to check the counter. If my counter is more than 3, then I step is equal to 10, and my counter is equal to 0. Else my counter is equal to my counter plus 1, equal to my counter plus 1, and I step is equal to 13. And we done here, and if and else I step is equal to 0, and then and if. Okay, I step, I stop, and I stop. Great. Okay, all the programs done. Now we can build it. Make sure no error. I hope it's no error. Okay, then we can download the project. Okay, then we can change the run mode again. Okay, then we can download the program. Turn the pay mode. Okay, now you see some stuff is stopped, and completion is okay, and the position is see the position here. Now we could turn the camera to let you see is our program is work or not. Let's do it. Okay, now we turn the camera. So the first thing I would like to adjust it to a bit more easy to see. Okay, now you see that it's stopped, its completion is okay. Now we turn on the power. Turn on the power. Now you see the power is turned on, and it's in ready. And we need to home it. So go to find the home. Home is here. Home it. and then to return it. And then finally we can know the position. I change to 0. Now we can start to run our sequence. Here, I think here. Let's go. Then because we set the position to 1000, then you see this servo will turn around 10 cycles or something. And now that minus 200, it return 2 times, and we will reverse 2 times, and we reverse one more 2 times, and then we will move the position to 1000 again, and it does loop it. And then now I would like to stop it. I will stop it. Okay, then it will run the cycle. Okay, done. Okay, I think it's a very small tutorial. I'm sorry that to make it very long, but I hope that you have a basic concept for OBB and how to use interface, properties, methods, and extend the function block. I hope you have some basic concept. So thanks for watching this video, and I hope I can see you next time. So have a good day. Bye bye.